So with longevity, a lot of these people, they say, okay, maybe meat is healthy, but maybe we should be limiting it because there's mTOR, there's IGF-1, or they make up all these little, they get into this minutia over some study that says something that says, oh, you're going to live a shorter time. So where do we stand with longevity?
Well, with the longevity question as it relates to meat, I think it's a non-issue. I think mTOR has been, mTOR is again, all these things they exist on a spectrum, and some expression of mTOR is phenomenal and necessary for growth, and some of it is a little bit too much and probably problematic. I don't think that a diet that's based on animal protein is of necessity going to cause issues with mTOR or any other signaling pathway. And in terms of longevity, I would look at more on a day. I don't look at meat, for instance, and protein on a meal-to-meal basis. Like, do I get 20 grams this meal or 30 grams this meal? Or what's the most that my body can process in one meal? I look at protein and amino acids in particular in this great pool, this vast reservoir that we have, on maybe a 3 and 4 day cycle. So as long as I get 350 grams of protein over the course of 3 or 4 days, I know I'm good. And it doesn't matter that I didn't have any one day, that I had 200 grams the next day. It sort of evens out. I think the body has a great ability. We can sequester energy in the form of fat. So fat goes into fat cells. Carbohydrate goes into glycogen, goes into glucose, glycogen stores. So we have this ability to take all these different things and save them for later, right? And I think we do that with protein. So I don't, in terms of longevity and protein, I want to make sure I maintain my muscle mass, right? That is a definer of longevity. If I don't have muscle mass, then I lose organ reserve. Now, what that means is over time, as I get older and older, if I don't maintain muscle mass, then if I start to atrophy, then my heart goes, you know what, I don't need to pump that much. My lungs go, you know what, I don't need to breathe that deeply. My liver says, I don't need to process that much. And the next thing, and my bones go, I don't need to be that strong, he's not doing that much. And over time, you lose organ reserve. Then, where you get into trouble, you know, you're 80, 85 years old, you get up in the middle of the night to take a leak, you trip over the cat, you break a hip, you get pneumonia, you can't cough out the sputum, you get congestive heart failure. That's what happens. People rarely really die of old age. They die of some organ that gave out finally because the organ reserve wasn't enough to sustain. And that goes back to muscle mass. So I want to maintain muscle mass. And to do that, I need to do the work, I need to exercise, and I need to have enough of the structural components and amino acids to make that happen.
Let me piggyback onto that because I think it's important. If we talk about how do we build muscle, what are the requirements? We know that you have to stimulate mTOR, but you need leucine to do it. You need a certain amount of leucine, and you need a full complement of amino acids. You have to have enough calories. It doesn't have to be too much, but you have to have enough. And so when we're looking at what's the best way to get your leucine in? And that's going to be almost clearly, the indispensable amino acids are going to come from animal sources. So if you're going to maintain your muscle mass outside of animal nutrition, you're going to have to eat even more protein to do that, to get the right amount. It's like building a car out of car parts versus building a car out of computer parts. I mean, yeah, you might be able to scrape enough plastic and metal out of a computer, but you're going to need 100 times as many computers than you are with a car that's already sitting there. So if we're talking about stimulating mTOR with regards to longevity or cancer, it's like, what's the best source of protein that I'm going to need to do that? Because we still want to stimulate mTOR. Our muscle building capacity revolves around mTOR, and we want to do that, and we can couple that with resistance training or something that stimulates muscle growth versus too much excessive mTOR stimulation through excess of calories, excess of insulin, the wrong types of protein, and then perhaps stimulating mTOR in tissues where we don't want to stimulate, like our liver and things like that. So I think when it comes to longevity, it's more nuanced. Anytime we learn something new, everybody kind of has this reflex of, oh my gosh, mTOR seems to be related to problems with growth and overgrowth and cancer, and then we got to make it zero. And we know that if you give low dose rapamycin to people, they have problems with sarcopenia because it's non-discriminatory. But whereas in the real world, in the real human body, which is far more complex than any of us ever imagined, it's more nuanced than that. And so you can't it's not binary. You just can't shut it all off completely and expect good things to happen.
We need both mTOR signaling and the complement to mTOR. mTOR is kind of anabolic. There are complementary catabolic signals, which are like AMPK. As Shawn is mentioning, rapamycin is an inhibitor of mTOR. And I think in lower animal models, there are suggestions that giving rapamycin can prolong life. I think as humans, in the scientific world, we've become too enamored with these like worm studies and mouse studies where we're prolonging the life. You know, they can do caloric restriction studies on mice and they prolong the life of the mouse. And I think that we understand a lot of those mechanisms. We certainly don't understand all of them. It might involve the sirtuin genes. They might have involved some differential control of mTOR. But when you look at mTOR, and again, this is a very simplified, oversimplified system, and we don't fully understand this, but there are these sort of two competing families of genes. And if you look at the relative contributions of stimulation of mTOR, of leucine, which is the most anabolic amino acid, and insulin, which is what you're going to get from eating carbohydrates. As we talked about earlier, you can fuel the car with either fat or carbohydrate. You don't have a choice. So, and you're always going to get some protein. And so the idea is that if you are giving yourself carbohydrates, your insulin is going to be higher. We know that is a pretty linear correlation. And if you look at the relative contributions of mTOR activation of leucine and insulin, it's very clear that insulin is much more robust and much more long-lasting. So one of the things I think is a great irony about this discussion regarding longevity and animal protein is that none of the people talking about it ever talk about the contribution of insulin to the activation of mTOR, because if they're limiting animal protein, then they have to be eating something. And it certainly is carbohydrates. They're not just living on fat. So they're using carbohydrates, and that is going to signal mTOR in a larger way. If you look at IGF-1 levels, IGF-1 being insulin-like growth factor 1, which is one of the ligands for the IGF-1 receptor, downstream from the IGF-1 receptor in the human body is the mTOR cascade. So IGF-1 could trigger mTOR. So sometimes we measure IGF-1 in the human body. What we see is that when people are fasting and they're not taking in any food, the IGF-1 levels are around 100 or 90. They go pretty low. But when people are eating ketogenic diets or high animal foods diets without carbohydrates, the IGF-1 levels don't go through the roof. They're sort of intermediate. But the highest IGF-1 levels are observed when people are eating mixed diets with both protein and fat and carbohydrates. Carbohydrates are going to push the IGF-1 higher than a solely animal-based diet. So there's a great irony in the discussion if we're just getting granular around IGF and mTOR. But both Mark and Shawn make great points that we know that protein restriction leads to loss of lean muscle mass, which is called sarcopenia. We know that inhibition of mTOR with rapamycin can lead to sarcopenia. And we know that sarcopenia is a predictor of poor functional outcomes as we age. And so this whole discussion, I think, loses the forest for the trees. We're not mice, we're not worms. Really, nobody wants to live to 150 if they're living to 150 with like a crappy quality of life, and I'm not even sure that that's necessarily the trade-off in the first place. If we just get a little more granular for a moment, what we've found, and this is quite an interesting nuance, is that the benefits of caloric restriction appear to be the sirtuin family of genes, and we can mimic those if we're in ketosis. And so we can get the benefits of caloric restriction now without calorically restricting. We just have to maybe adjust the macros a little bit, and it's quite easy to do if you're doing, a well-constructed primal diet, a well-constructed animal-based diet. You can be activating the sirtuin family of genes, mimicking caloric restriction in a longevity-based way in an animal-based diet. That kind of turns the whole thing on its head.